Welcome back to this deep learning playlist. Please consider subscribing to the channel if you are new here and consider watching all the tutorials in sequence to have a better grip on the subject.
Hello all and welcome back to the deep learning playlist. In today's lecture, we are going to talk about a common issue that you might encounter when you are working with neural networks. And this issue is overfitting. So what exactly is overfitting and how can you prevent it? Let's find out. So when we train a neural network model, the goal is to have a generalized model that can perform good enough on the new unseen data. However, sometimes the network can become too specialized to the training data and start performing poorly on the new data. And this issue is known as overfitting. We have discussed about overfitting and underfitting in details within a dedicated lecture in the previous machine learning playlist. So you can consider checking it out in case you haven't already. So the question is that how can we prevent overfitting? And within this lecture, we are going to talk around few techniques which will help you to tackle overfitting when you are working with a deep learning neural network model. So the very first approach in order to tackle overfitting within deep learning will be using more data if it is possible for you. So increasing the size of your data set is one of the most effective ways to prevent overfitting. And if you can use more data for training purpose, then the evaluation of your model will be even better. It will help the neural network to learn wider range of patterns and generalizations which can improve its ability to generalize to a new data. The second technique to tackle overfitting will be data augmentation. So this is a technique which is widely used when you are working in a computer vision project. Although we have not covered the computer vision part within this particular deep learning playlist, but we will cover that soon in future. But still, for the time being, I will try to give you a high level overview around data augmentation. So this is one of the technique when you do not have option of using more data when you are working with images, but still you will be able to increase the size of your training data by using data augmentation technique. So in a nutshell, this technique actually helps you to create more data or more images by applying some sort of transformation over the existing images that you have, just like rotating or flipping or adding noise to audio data for that instance. And this method can help the neural network to learn more robust and invariant features. Augmented data is driven from original data with some minor changes, as you can see on your screen. So in the case of image augmentation, we make geometric and color space transformations like flipping, resizing, cropping, or tuning the brightness or contrast of the image that you already have. And using these techniques, we increase the size and diversity of the training dataset. In future, we are going to discuss this method in details when I will create computer vision project tutorials within this channel. And let's move ahead to the next technique, that will be using dropout methods. So I'll try to explain what it is. Dropout is a regularization technique actually that randomly drops out some of the neurons in the neural network during training. So pay attention on this figure where we have two neural networks. The first one is the usual one that you have already seen before. It is a completely dense and connected neural network where all the nodes within each and every layer are connected with each other. But on the other hand, if you will pay attention on the second image, lots of neurons or perceptrons have been deactivated, as you can see here. And this is a very effective method in order to tackle overfitting, because this particular technique prevents the network from relying too much on the perceptrons of each and every layer and encourages the model to learn more robust features. So basically the idea is when you are using too many perceptrons within all the layers of your deep learning neural network, the neural network actually starts learning each and every minute details and patterns of the dataset. And by doing this thing, you are bringing the issue of overfitting by relying really heavy on the training data, because it is capturing the details of your training data very minutely, in so much details that when it sees the new unseen data, it won't be able to perform good over there. And this is why using the second method of dropout layers, we are not relying too much on the training data in order to do the prediction, because we are learning more robust and invariant features in order to do the prediction. If you will pay attention on this figure, I have provided the snip of a code that is showing you that how are we actually importing the dropout layer module. And using this particular code line, we are dropping 50% of the neurons from our neural network model. I understand that within this playlist so far, we are covering only the theoretical part and we have not yet covered the practical or coding part. But do not worry, as soon as I end up covering all the theory, the next idea is to upload only guided projects, real life projects that you can add within your portfolio, and only those project tutorials will be uploaded on the channel. Project in terms of machine learning, deep learning, computer vision, etc. And within this year only, you will be able to find a lot of projects within this channel only that you can use within your portfolio or within your CV. So please make sure that you subscribe to the channel and also press the bell icon so that you will be get notified every time I am uploading a new video. And this was all about the dropout layers. Now let's move ahead and discuss the next technique to tackle overfitting. And the fourth technique in order to tackle overfitting would be using early stopping. So let's move ahead and discuss this particular technique in details. Please pay attention to this particular figure. On the x-axis, we have the value of the cost, and on the y-axis, we have number of epochs. And this figure is actually showing us, let's say within first epoch, this is the loss with respect to the testing data, and this is the loss with respect to the training data. And let's say within the second epoch, this is the loss with respect to the testing data, and again this is the loss with respect to the training data, and so on 3, 4 and 5 over here. And if you pay attention, then after the fifth epoch on the figure, the loss with respect to the training data is now no longer decreasing efficiently. On top of that, the loss with respect to the testing data has now started increasing, which means technically speaking, after the fifth epoch, the training of the model has no longer remained efficient. It is not learning any efficient weights in order to perform well as a generalized model. So wouldn't that be a good idea to stop the training of the model exactly at this point? And this particular method of stopping the training of your model when the training has no longer remained efficient, this particular method is called early stopping. So this is another topic for preventing overfitting. In a nutshell, this involves monitoring the performance of the network on a validation set during training and stopping the training when the validation performance starts to deteriorate. This can help to prevent the neural network from overfitting to the training data. Early stopping is a very different way to regularize the machine learning or deep learning model, and it simply stops the training as soon as the validation error or the loss with respect to the testing sample reaches to a minimum, like it has over here. Again, if you will pay attention to the figure on the right hand side, I have provided you the code to implement early stopping, and this is exactly how you are specifying it. Again, we will discuss this particular technique in practical once I start uploading coding projects within this channel. And the last technique that I want to talk around would be using the weight regularization technique. So weight regularization is a technique that adds a penalty term to the loss function during training, which will then encourage the network to learn smaller weights. In case you have already covered the machine learning fundamentals, then you would be already aware with the regularization techniques like L1 and L2 regularization. However, in case you have not yet covered that particular topic, then please consider accessing the machine learning playlist below from the description box. I will provide you the link over there, and consider checking out the video where we have discussed the weight regularization technique in details. But still, in order to provide you some high level overview, this regularization technique is actually applying a simple logic that it adds a penalty term to the loss function that you are using. This loss function could be mean squared error or mean absolute error, and along with that, an additional penalty term will be added. This method will help to prevent the network from overfitting to noisy or irrelevant features. And in a nutshell, these are the top 5 techniques to tackle overfitting within a deep learning neural network. Please remember that it is important to strike a balance between fitting the training data well and generalizing to new data. And with these techniques in your toolkit, you will be able and well equipped to build more robust and reliable neural networks. Thank you very much for watching till the end. Also be sure that you subscribe to the channel for more data science tips and tutorials. You have a nice day ahead. See you in the next video.